Welcome once again. This is Introduction to Elementary Physics, Lesson 3 of the topic Vectors. Lesson 3 is divided into two parts, parts A and B. In part A, I will be talking about the Parallelogram Law of Vectors, and in part B, I will talk about the Triangular Law of Vectors. If you have not viewed lessons 1 and 2 of this series of the topic Vectors, do well to view them. The link to lesson 2 is given in the description of this video, while if you are able to locate lesson 2, the link to lesson 1 is given thereof. Do well to subscribe to this channel, hit the like button and also the notification button so that you can always get updated anytime new lessons are uploaded. Thank you very much. Let's begin. So in lesson 2, we started talking about the resultant of two vectors. Here we are going to continue with case 3. Refer to lesson 2 for cases 1 and 2. So in case 3, if we have two vectors inclined at an angle with respect to each other, how do we find their resultant? This is what I mean. Maybe this is our point of action. This is the first vector acting in this manner, and then this is the second vector acting in this manner, both of them being inclined at an angle theta with respect to each other. This is vector Q and vector P. So you can see that in this case, we cannot just simply add or subtract, just like we had in case 1 and case 2. How do we now go about this problem? This is where the use of the parallelogram law or the triangular law comes into play. Anytime you have two vectors inclined at an angle with respect to each other, you can use the parallelogram law of vectors or the triangular law of vectors to get the resultant. You can also use scale drawing, but like I did mention in lesson 1, scale drawing is not captured in the scope of our discussion in this series. Okay, so let's quickly take a look at the parallelogram law of vectors. This law states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the vectors represents the resultant vector in magnitude and direction. This law is simple to understand. You don't need to stretch or crack your memory so much to commit it to heart. Okay, it's just to know that when you have two vectors acting at a point, you develop the system into a parallelogram. How do I mean? This is a case we are looking at. If I want to go by parallelogram law of vectors, what I would do is I will draw a side that is parallel to one of the vectors Q, and then draw another side that is parallel to the other vector P. So you can see that I now have a parallelogram with P and Q indicating the adjacent sides. So according to this parallelogram law of vectors, if I want to obtain the resultant, I will have to locate the diagonal of the parallelogram that is drawn from the point of intersection. You know, there are two ways of locating or of getting a diagonal in this case, okay? We can have a diagonal drawn from this point. But if we go by this, we are going to be wrong, because the law states that the diagonal must be drawn from the point of intersection of the two vectors. Now, where is the point of intersection of the two vectors as they act together originally? This is the point of intersection, okay? So this means that this diagonal is the correct specification of the resultant, okay, of the two vectors acting at this point. Now, irrespective of whatever the angle is, whether it is an acute angle, an obtuse angle, or a right angle, this is the principle for finding your resultant using the parallelogram law of vectors. Okay, so the mathematical representation of the resultant is given by cosine rule. I will strongly counsel that you go back to mathematics and review your cosine rule, just in case you are not familiar with that, because the scope of this lesson does not capture the explanation of cosine rule in details. So from cosine rule, we have it that r squared is equal to p squared plus q squared plus 2pq cos theta, or r squared is equal to p squared plus q squared minus 2pq cos 180 minus theta. Simply put, anytime you are having two vectors acting at a point at an angle to each other where you cannot just easily subtract or add, you resort to any of these equations to get your resultant. Now, the interesting thing is that whether you are using parallelogram law of vectors or triangular law of vectors, these two equations are what you can use to get the resultant. Okay, so this brings us to the end of part A of lesson 3 of the topic vectors, the parallelogram law of vectors. Mind you, or remember, the takeaway from here is that if you have two vectors inclined at an angle, you can use parallelogram law, and then from parallelogram law, you obtain the resultant, which is given by any of these two equations specified here. Thank you very much. In part C of this, in part B of lesson 3, we are going to be talking about the triangular law of vectors. So see you in the next lesson. Do well to subscribe and hit the notification button so that you can get carried along. Thank you very much.